Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's webinar, Learn How to Massively Scale Your Multiplayer Game, brought to you by Gamasutra and Redis Labs, and broadcast by UBM. I'm Alyssa Macklin, news editor and associate publisher at Gamasutra, and I'll be your moderator today. We have just a few announcements before we begin here. You can participate in the Q&A session by asking questions at any time during this webinar. Just type your question into the Q&A text area located to the right of the presentation window, and then click the Submit button. At this time, we recommend you disable your pop-up blockers. The slides will advance automatically throughout the event. You may also download a PDF copy of the slides by clicking the Download Slide button located below the presentation window. If you are experiencing any technical problems, please visit our webinar help guide by clicking on the Help link below the presentation window. In addition, you can contact our technical support helpline, which is also located in the webinar help guide. Now on to the presentation, Learn How to Massively Scale Your Multiplayer Game. Discussing today's topic is Madhukar Kumar, Redis Labs VP of Technical and Product Marketing.
All right, thank you very much, Alisa. Let me go ahead and get started. As Alisa said, my name is Madhukar, and I'm responsible for product marketing, technical marketing, developer advocacy at Redis Labs. And I wanted to take the opportunity to talk about three things today. I want to keep it simple and stay true to the topic, which is how to massively scale the multiplayer games of today. But first, I want to talk a little bit about trends in the gaming development. Number two, we'll talk about some gaming use cases specific to scalability, and then we'll talk about how Redis and Redis Enterprise helps a lot of gaming companies today and others that use our open source version as well to scale their game. So let's go ahead and get started. When we talk about trends, what might come to your mind is, okay, what makes you an expert? Why do you think you know all the trends? To tell you the truth, we have about 7,400 customers total across Redis Enterprise, and a good chunk of them are gaming customers. And these are customers often who would start really small, and sometimes they would become really big, and sometimes they go out of business. So we have a lot of experience with gaming. And as part of my team's charter, what I do is I talk to the customers, especially in the gaming, almost on a day-to-day basis. So when we talk to some of the recent trends of what's going on in the gaming industry today, the first one that always comes up, and before I get into this, obviously I will say that there are a lot more trends than just three. But when I look at all of the different trends that's going on right now, I wanted to zero in on just top three, because this webinar is not about trends, it's just about top three so that we can talk about scalability. But all of these three trends that we talk about affect scalability in one way or the other. And one of the first things that always jumps up whenever I speak to any customer is if they are building something new, then they're building it in a microservices architecture. In fact, I've had a few conversations in the last month or so where customers are coming and telling us that what they have already built, and if they were not in microservices, then they're rebuilding those in microservices architecture as well. And this has been around for about 5 years, so I won't get into the details of what exactly is the microservices architecture, but there are a few things over here that I do want to touch on. Of course, the benefits is that if you build something out in a microservice, then you get the best of the breed in terms of the language or the technology stack that you use. You get decoupled team development as well. So your one team could be working on one service purely on Python, and the other one could be working purely on JavaScript, and they can all move in their own parallel tracks without affecting the overall release time. And number three is, of course, it's easier to scale because now you have these services that are probably running inside containers, and then you have orchestrated those containers. So it's easier to scale parts of your application versus taking your entire application and then scaling it horizontally or vertically. But this, again, is nothing new. This is something that people have been talking about, especially in gaming, and they're moving towards this. What is new, though, in terms of microservices is that now that a lot of companies have started to use it, they've realized that there are some complexities associated with it. And the biggest challenge, at least that we see right now, is the complexity that comes along with data. So if you look at this and you think about, okay, on the right-hand side now, each one of my service or each one of my microservices is domain specific and doing their own thing. How do I make sure that each one is now syncing the data with each other? So if it's something like a transactional website or web application, then this architecture runs into some major challenges. But a lot of development is now around how even for these architectures, you could potentially use like an event-based mechanism where each one of the microservices is publishing, subscribing in order to share data that is consistent or eventually consistent across all of the services. Now, again, some of the use cases, it works great. There are some use cases which requires atomicity or some use cases that requires maybe e-commerce-based transaction that doesn't really fall into this. But a majority of what we see is microservices moving towards an event-based architecture. Number two that we see a lot is infrastructure as a code. So now what do I mean by infrastructure as a code? Well, I started off my career almost 20 years ago as a developer, and I remember when virtual machines were introduced. And that was a big, exciting new thing because now then I could go in and no longer needed somebody to go assign a virtual machine to me. I could just go within my own laptop, if it was big enough or a server, I could go create my virtual machines. And infrastructure has come a long way since then. In the sense, from virtual machine, we went to containers, and now from containers, we have gone into orchestrating the container. But if you think from an overall perspective, there are two or three major things that's going on over here. One is now you have much more granular control of your application as a developer from the point of ideation, prototype, all the way to the production. So by that, what I really mean is now I can create an entire application, even if it's a small application or just my own microservice. I can do Docker Compose, and I can create an entire environment with the network and script it in a way. So I can even go into my packages, I can install all the packages, script it in a way. So when I move this into production using nothing but configuration, I can change the authentication in each environment, and then I could scale up and scale down as I wanted. So a couple of advantages could be I could just take this, and let's say I know that certain time my traffic is going to be extremely high. I could run the script to now spin off an entire cluster of brand new containers running the same service. And then when the traffic goes down, I can utilize the same script to scale it down. So things are obviously become a lot more closer to what the dev and the DevOps can do. But it also leads to a lot of discussion around complexity. One of the big advantages, because you can write the entire infrastructure as a code in YAML files, you could check in, check out, you can go back and see what had worked in the past, what changes happened, and you can collaborate with your team as well. So a lot of the gaming companies that we talk to, they definitely have started to use infrastructure as a code. The third one, which I think is pretty interesting, is, of course, goes back to, and it's related to both in the sense, everything is moved to the cloud, everything is a microservice, or everything new that's coming out is a microservice, is moving to the cloud. And of course, what we also saw was that, we're trying to be very fast and agile. So even in that sense, microservices really help. But what if we are working on, there's an entire team that's working on a brand new set of features, and those features is disruptive enough so that if you decided that you want to go live with it on a particular date, there's a lot of risks involved with it. So one of the things that has started to show up quite a lot in at least 2 or 3 different gaming customers that we have spoken to is something called a feature toggle. And what a feature toggle really is, think of it as a switch where you go in and you create a feature, but it's triggered by a configuration. And that configuration is completely decided by you depending on the environment. So here's an example of what we're looking at, where maybe you have a configuration that says, my feature name is release the Kraken, whether it's true or not. If it's true, then you show the features. If it's not, then you do not show the features. And essentially what you can now do is you can continue to write code with every new deployment that goes on. This is still going on, but you haven't really switched it on. And you do your unit testing and so on. Once it's in production, then what we see a lot of customers do is they will first switch it on by the user segment. So they might just switch it on for maybe first 10% of their customers. Then they might switch it on for about 25% of their users. And then finally, if nothing's gone wrong, you go and enable the configuration for your entire population, and now everybody can see it. So you reduce the risk, but at the same time, you are not falling back to a waterfall development style. You're doing deployment every day, and it's all done through what we call as feature toggle. All right, so we looked at some of the things that's currently on the top of the minds in terms of when we talk to the gaming customers. But let's take a look at what are some of the gaming use cases that is almost entirely true across different gaming customers. But before I get into that, one of the things that we do here is that almost everybody we talk to in gaming, they either use Redis or they use some sort of caching. In fact, one of them jokingly said that if you are in gaming, you either use Redis or you're out of business. And if you're not familiar with Redis, then people describe it in a couple of different ways, but mostly it's known as an in-memory open source database. You could also call it, because of the use case, you could also call it as an in-memory data structure store as well. And the reason why it's called an in-memory data structure store is because unlike a classic memcached caching-based solution, it has a lot more. Think of it as a memcached on steroids, where it's a key value, but you have other data structures as well. So I could, of course, the most basic data structure is string. I could store anything within a string, but there is also things like bitmaps and bitfield. If I want to find out if all my users are logged in or not, I could have just a bitfield to record 0 or 1 or whether they are logged in or not. And within a few milliseconds, I could essentially see my entire customer base of who is logged in at any given point of time. The other one that is used quite a lot are hashes. And hashes is a classic key value again, or an attribute and value. A list is self-explanatory in the sense it's a classic list where you can either pop from the left or the right and you continue adding to it. But the two very powerful ones that is used quite a lot in some of the use cases that I'm going to talk today are sets and sorted sets. Sets is just, again, self-explanatory. You can put objects in there. But when you put sorted sets, these values are unique, and they are ordered or sorted by the scores associated with each one of them. That's one of the key things that is used for a gaming use case within leaderboards, and I'll talk a little bit about that. Then there are others like geospatial indexes and hyperlog log, but the one that we'll also talk about today is something called streams, which is used for an event-based architecture, which is one of the things that we saw as the trends earlier during the presentation. So when you combine all of the different data structures with the ability to be able to run entirely off memory, so if you didn't know, Redis is written in C, it runs entirely off in memory, unlike a classic relational or any other NoSQL database that still works off of a disk. So the flexibility in terms of the data structure is great, but I think what's more important is the fact that because it runs in memory and it's in C, it is extremely fast. In the sense, we're talking about a few milliseconds, not even a few seconds. Based on those data structures, then, if I now try and map it back to where most of the gaming customers really use a Redis for, these are some of the use cases. Number one is leaderboards. Number two is session stores, because you want your users to be able to log in and instantly get all the data, the profile data available to them across all the devices. So you cannot, it's pretty expensive to go back into your disk-based database and then try and pull that data out every time somebody logs in and logs out. You can also utilize pub and sub along with streams, which is another data structure within Redis for event-based architecture, which essentially means you could use it for chat features within your game, but you could also use it internally in your backend services as an event-based architecture for your microservices. And then we'll talk about caching as well, which is the most common use case for Redis and Redis Enterprise. And then finally, how do you scale very large data sets when you've started to use that data within your memory? So if I take each one of them and double click, so to speak, then in general, if you think about it, your major data, the way I think about it, there are two kinds of data. There's data that is read quite a lot, and then of course there's data there is a little bit of more write, and then there's some data that you have both read and write, which kind of sessions falls in that bucket. But majority your data sources is either based on disk storage. You can be using something like an S3 for running your analytics or whatever in the backend systems. You have your classic relational databases. You might be running MySQL, Postgres, whatever you use for relational. And then you might also have APIs, which in turn is aggregating your data, and then is an endpoint which might be talking to your front-end client. Now, most of these, if there are, the reason why you end up using something like Redis for cache is because A, it could be often very expensive if for every read-intensive feature, you're going back to your disk storage or you're going back to your database. You're mostly reading, and if it's mostly reading your user profile, for example, then there's no point going back to your database for every single query. So typically what you would do is you would cache that. The second reason you would do it is because you want to reduce the overall network calls that's going to your relational database. And the third reason you might want to do it is you want to reduce the load, because a relational disk-based database is not typically meant for a lot of reads. So in general, what you do is you use something like a list, or you could use a typical key value string inside Redis. And with the key, you associate a value that goes inside the cache. Now, the reason why Redis and Redis Enterprise really shines over here is because you have very granular eviction policies. So every time you define a key value, whether it's in the list or any other data structure, you can define what that eviction policy is. Now, there are different ways you could do caching. You could do a read-through cache, or you could do as what you see in the screen right now, where you write to the cache as well as the storage every time you do a write. But the most common one that we see is you hit the cache first. If you get a hit, then it's all great. You get back the data in milliseconds. If it's not, which is a miss, that's when you go back to your data layer, pull the data back in, and then build the cache. And you could use it as an LRU cache, which is the least recently used policy. The second one, which is kind of an extension but goes into a little bit more of a read and write, is user session. And this is where we see a lot of gaming customers use Redis and Redis Enterprise quite a lot. It's because it's very expensive to go back and read user profiles every single time, whether you're through different devices or if you logged off and you log back in. And that's where we see the session data. You can bring it, you can store it in a hash, or if you're using Redis Enterprise, you could also use Redis JSON module to store your entire session data inside a JSON object as well. Number three, which is very, very common in gaming, is leaderboards. And if you really think about leaderboards, it's, people think of it as very simplistic. It's true that when it came out back in the 1970s, with the most basic games, it was very simplistic. It was just a ranking of the top 10, and these were absolute scores with the name of the players. But in the most recent times, you could say that the leaderboards kind of fall into two different categories. One is an absolute, and the other one is a relative. The absolute leaderboard is when you have the exact score shown in your leaderboard. But the relative could be a combination of multiple different attributes that does calculations and show it. But the challenges for creation of leaderboards today is far more than what you had even a few years ago. For example, if I'm a gamer, I would like to see my leaderboard score across different devices. I might be on my computer, but I might also want to quickly then check it up even in my phone, because I want to share that with my friends over Twitter or using Discord or something. I want to also be notified if the leaderboard changes. If I'm losing, if I'm winning, or somebody that I'm playing with goes up or down, I want to be notified. Number 4, I want this to be real time. I don't want this to be even a few seconds old. I want this to be as real time as the rest of the game is. And when you scale to millions of users, you have the challenge of a massive scale problem where you need to make sure that you are doing the calculations across millions of users in less than a second, and then be able to show it to your users and be cognizant of all the other complexity that goes along with it. Thankfully, inside of Redis or Redis Enterprise, the thing that makes it, again, very friendly to the gaming industry as well as the gaming companies is the flexibility and the speed that's associated with Redis and Redis Enterprise. So as I talked about earlier, one of the data structures that's available within Redis is called a sorted set. And to give you a very quick example, a sorted set you simply do by doing a command like zadd, and then, of course, there's the key, which in this case is scores, and then you put a score along with the name of who that score belongs to. It's the most simplistic leaderboard that you can create. So in this case, I've added 2 scores. Jane is at 100, Tom is at 96. Now I could do things like show me the top 2, and it'll give me the name. But I could also do a range and say, show me between this and that. And all of this, I can now scale it massively, because if you're running inside Redis Enterprise, it is built for scale. So you could run the latest benchmarks that we did. You could do 200 million operations per second with less than a millisecond of response time. And we were able to do that in less than 25 EC2 instances on AWS. The other one that jumps to mind, of course, one of the use cases is PubSub. And again, PubSub was very simplistic till a few years ago, but it has it's become a little bit more complex, and it has its own challenges now. But where would you use PubSub inside gaming? You could use it in the backend for job queues, but you could also use it for chat between different gamers and users. And finally, you could use it for notifications as well. If somebody wants to get notified for the use case that we just talked about, which was leaderboards, you could use that as well. Typically, the way it works is that you have a publisher, or you have a bunch of different publishers that are publishing events, and then you have a bunch of different subscribers that are listening to different events, and then they're doing something with it. You either do something with it, convert it into a job, or you're just consuming it, in which case you're a subscriber. Now, within Redis, due to the flexibility in the data structure, there are actually multiple different ways you could do it. One is straight up PubSub, but it's a fire and forget. So that means there is no persistence. You cannot look back to your queries. It is all real time and it's live. So if you're one publisher and you have many subscribers listening to it, if one of those subscribers goes down, when the message was fired, then if you missed it, you missed it. You can no longer and go back and get it. The other way you could do this is through lists. And within lists, you could have, again, multiple subscribers, but each one has their own list now. But there's a tighter coupling. And again, there is no look-back queries here. You could also use sorted sets, but you have similar issues. And now you have to keep a track of the timestamp by maybe using the timestamp as one of the attributes within your sorted sets. But what we did recently was, as part of 5.0, a new data structure that was introduced was streams. And streams is kind of custom, not custom, but it's purpose-built almost for publish and subscribe, because you could have multiple producers, you could have multiple consumers or subscribers, and each one of these consumers or subscribers could read the different topics at different speeds. So we have this notion as consumer groups as well. So you have a rich choice of options, whether if they want to read streaming data, or you could look at the data at rest. So you could look up your queries backwards as well. There are consumer groups. So each consumer group, you could define rules to say, There are certain consumers that would only listen to this topic and so on. You control the full data lifecycle. You have full fast lookup queries, and you have automatic eviction policies that you can set up as well. Which now brings me to Redis Enterprise. What's the difference between Redis and Redis Enterprise? So if you think about it, typically the way most of our customers start utilizing Redis and Redis Enterprise is just as I talked about earlier. You have a database or you have a data layer, which could be your file storage, it could be your API, it could be your classic SQL, NoSQL database. And now you set up an open source Redis node in between that. In between, in the sense, your application is checking with Redis for caching. If it exists, then it goes back. Then it goes back to the app server. If it doesn't, then you're basically going back to the database. Now, what happens over a period of time is that because of its performance, we see customers start adding more and more nodes. So you had one instance of Redis, and now you have more than 25 gigs of your user session that was sitting in one node. It can no longer manage that, so you added 5 more. And when you add 5 more or you start to do sharding, now what you have to do is to go back into your application and then keep a track of where your keys and your key spaces are. Because if you don't, then you will have to run into issues that you are querying off a node, but that key doesn't really exist in that node. It sits somewhere else. This is where Redis Enterprise comes in, where you can massively scale it with our cluster, because at the end of the day, you only get one endpoint. And within that endpoint, you decide today that you want to use 2 gigs, and tomorrow that could be 2 terabytes. In the back end, using our patented clustering technology, we go in and do multiple shards, we replicate it, we do active-active, so that it's also geo-distributed. So you never really have to worry about adding multiple endpoints to your application. Is still one endpoint. You don't have to worry about where the keys are sitting or how it is being sharded in the background. It's all seamless to the UI. Now, the other thing that might come to your mind is, okay, that's great. Now, let's say I went from a few thousand or a few million users to now multiple millions, and now my data that I was storing, whether it was session or even cache, and session plus cache now has gone from gigabytes to terabytes to even petabytes. What happens to the cost? Because now I'm paying for all of that cost in memory. So one of the other things that you could do with Redis Enterprise is that you can set up what we currently have as Redis on Flash. And Redis on Flash, it uses intelligent memory tiering to take core data and then in the backend automatically move the least recently used data or core data to Flash. And over a period of time, if they get used, they move back, but it's seamless. You get a very minimal hit on the overall performance. Still in a few milliseconds, your response time is still great, but then your cost is not super high as you would be paying for RAM. But more recently, of course, there is RAM, which is more expensive, and then there is Redis on Flash, which is less expensive, but near similar performance. Intel recently announced, of course, a brand new product called persistent memory, and that bridges the gap between the two as well. So now if you have, let's say, a requirement which doesn't have as much throughput as would needed in RAM, and it cannot be as slow as this as well, and you have a little bit tolerance on the cost, then there is something called Intel's persistent memory that you could use over here as well. Finally, the last thing I would say before we open it up for questions is that, like I said, we have a number of different customers that currently use Redis Enterprise. And one of them is, of course, Jelly Button Games. Before they came in, they had roughly about 1,000 users. And within a few days, I think less than a month, they went up to 3.5 million users. And they use Redis Enterprise for, of course, not just caching, but high-speed transactions. They use it for session stores. They also use it for time series data as well. And one of the things I didn't talk about was multiple modules that can be added on top of open source Redis in Redis Enterprise that turns the 8 data structures into other data models as well, or you can add different data models. And one of them could be time series. So in addition to streams, there is now a data structure called time series that's purpose-built for time series data, where you want to capture every single event by the second or by the millisecond. And then you want to utilize that entire event to either do computations or run analytics in the background if you wanted to, or recreate an entire experience if you wanted to by going back into the time, because it does look back, it does aggregation, and so on and so forth. With that, I'll hand it back to Elisa so that she could now read some questions. But before we do that, one of the things I do want to call out is within Redis Enterprise, there are multiple ways to get started. You could go to redislabs.com/get-started, and with Essentials, that's $5 a month, you can go get started within a few minutes. You get an instance right away. It's on a multi-tenant environment, and you're able to go and test it. And there's also a free tier over there. If you wanted to get your own VPC on our infrastructure on AWS, that's the Pro version. Or if you wanted it completely on your platform of your choice, whether it's GCP, Azure, or anywhere else, AWS, or even your own data center, then that's Ultimate, as well as software. Software, basically, you could install it in Docker, or you could install it in your VM, or you could orchestrate it with Kubernetes or Docker Swarm as well. It's also available on Pivotal as well as Red Hat OpenShift. And with that, I will now hand it over back to Lisa so that she can read some questions.
Thank you, Madhukar. All right, now before we begin with today's Q&A, please fill out the feedback form that is open on your console. To complete the form, please press the Submit Answer button at the bottom of the page. Thank you in advance for filling out that feedback form. Your participation in this survey allows us to better serve you. And now on to the question and answer portion of our event. As a reminder, to participate in the Q&A, just type your question into the text box located below the media player and then click the Submit Question button. Our first question here reads, you mentioned Redis Enterprise is a multi-model database. What other data model does it support?
Yeah, so it's a really good question. Like I said, Redis Enterprise has what we call as an API for modules. And you could write the modules in either C or in Zig. And we have a big community, open source community, as well as Redis Labs, which is the company that sponsors open source Redis. We build Redis Enterprise modules as well. And with those modules, you can add multiple models, which is why we call it a multi-model database. The other models that are available right now is one, Redis Graph, which turns it into a graph database. There's Redis Time Series, which we just released a few weeks ago. There is, of course, Search, which turns Redis into a super fast, less than a millisecond response time search engine. There is Redis JSON. And then, of course, there's probabilistic data structure as well. One of the other modules that we just added is called Redis AI. And what it allows you to do is to, in fact, run your TensorFlow models within Redis as well. So it can go and look at the data. You can load up your TensorFlow models or your PyTorch models, and it can run against the data within Redis, and again, be able to serve those models in less than a millisecond. But to answer your question, the reason why we call it multi-model is because now it has graph, it has time series. Of course, we talked about streams. There is JSON, there's probabilistic data structure, and then, of course, there's search.
Sounds great. There's a follow-up to that first question. Question asker would like to know, how can time series data be used in game development?
Yeah, so a bunch of different ways to do this. Of course, there is for monitoring, you could do that. In the sense, time series comes with its own adapter, so you could connect it to Prometheus and Grafana. And as you scale up and scale down, you can utilize for real-time monitoring of your systems. But the other much more, I would say, direct use case that does come to mind is, let's say you're a multiplayer game and you're keeping a track of all your users' movement and maybe location as well as the action. So for example, if I'm player A, I take a shot at another player, player B, and I take it at time, let's say 9. Now the other player might have moved by the time it registered on the server. So if you stored every single movement, every single event, every single location inside a time series across different users, then if I claim to have made that shot at a timestamp, whatever 9, you could go back at the timestamp for the other user and be able to see what was the location and match it and see if it was an actual shot that completed or not. And all of this happens in milliseconds across millions of users. You're no longer going to the database or trying to do it backwards in time and so on. And then using this time series, you could replay a bunch of different events within your game as well. So it's very directly used over there. But the other one, like I said, you could also use it for events. If there are multiple different microservices, you might be posting events based on timestamp. And as other microservices come up, they can go and do backwards query to figure out what had happened and catch up.
All right. We do have another question about Redis Enterprise, which is, does Redis Enterprise support data durability?
Yeah, 100%. So in fact, Redis Enterprise, like I said, if you went with the cloud version, it does give you full active geo-distributed architectures as well. And you can run it in multi-cloud if you wanted to. Like you could have some Redis instances running in GCP, others in AWS. And so that gives you redundancies and durability as well. And in effect, it's 100% active as well. The reason why it's different is we also do multi-master. So you could have multiple masters running at the same time.
Sounds good. And it looks like that's all we have time for today. For more information related to today's webinar, please visit the resource link open before you. Within the next 24 to 48 hours, you will receive a follow-up email with details and a link to today's presentation on demand. And thank you for attending today's webinar, Learn How to Massively Scale Your Multiplayer Game, brought to you by Gamasutra and Redis Labs. This webinar is copyright 2019 by UBM. The presentation materials are owned or copyrighted, if that is the case, by Gamasutra and Redis Labs, who are solely responsible for its content, and the individual speakers are solely responsible for their content and their opinions. On behalf of our guest, Madhukar Kumar, VP of Technical and Product Marketing at Redis Labs, thank you for your time and have a great day.